Okay, so this is how to use the hole and thread features within Fusion 360. So let's go on the top view. We're going to create our sketch. So all we're going to do is make a plate as such. So let's do 50 by 125. Let's get a decent sized plate. Okay, into solid, extrude, and let's just do an 18mm steel plate. Like so, it's a typical steel plate. So we're going to use the hole tool now, which is obviously H hotkey, hole, or the hole on the main toolbar as well. So we're going to select our face. Okay, so I'm just going to orientate around to the top. So this is how to do a single placement only. So I'm going to put a reference in. I'm going to say that this is going to be 5mm away from that edge to the centre. And my second reference at the top is going to be 10. Like I said, now obviously we know that hole is too big, it's going to cut out quite an extensive chunk from my steel bar. So I'm going to want a through all hole, which is why it's not done like this. I want a simple hole. I'm going to say actually my hole is going to be 4mm in 12mm in diameter, 10mm, let's get 8mm in diameter there. That's just a simple through hole, as if a drill did it essentially, as if like a drill hole was there. So using the same command again. Okay, this time we're going to look at a clearance hole. It's a simple and a clearance. So again, selecting my reference. This time I'm going to do 10mm. Second reference I'm going to do is 5mm. 10mm again. So this time I've got 20, just distance it away. So this time I've got a clearance hole. Again, it's going to be through all. So now I need to put what my clearance is. So I'm going to say this is going to be a hex bolt. It's going to be an M10. Normal fitment. Okay, so then now I've got a clearance hole for an M10 in there as well. Going from the top again, using the hole function again. This time I'm going to choose my reference as 30. Let's do 40 because it's quite a big hole. And 10. Let's do 35. Get that a bit further down. So this time I'm going to use a tapped hole. Okay, thread offset, so it's a through all rather than an offset thread. Again, I'm going through all again. I don't want to tap to a distance. This time I'm going to choose a 12mm hole. M12 comes 175 coarse thread, class 6H, and I want a right-handed thread. Now I have a standard drill hole, a clearance hole, a tapped hole. So when I come out, I can see that my thread's got a cosmetic or visual thread there as well. Again, so back on the hole again, let's choose this one again. This time we're going to choose a taper tap. So again, just going to do my references, reference them from the side. This will be 55, that's 45, 50 maybe. Second reference 10. Okay, this time then I'm going to use my taper tap. I'm going to say my top is through all, and I'm just going to say that I've got a internal taper. I've got one, yeah, ISO taper tap. I want maybe a 1 RC3 and for it a bit big. A quarter, it's fine. Quarter range. Now I've got a nice little taper tap. So as you can see, it's straight through it, and then as you get down to the bottom, it tapers off for the hex bolt with a shoulder. Okay, last one on the hole type, you've now got a you have a counter bore. So obviously we have two types of counter bore. So we can do a counter bore, you can see it's 16, and then in depth, let's do all. We've got 10.2, 1 mils, that's by 11, so we've got a nice little counter bore. So it's obviously counter bore, so again you might think actually that counter bore is pretty tiny. You've got a depth of 1 mil, let's put that to 5. Let's keep that counter bore depth, and I'm going to put an internal depth of 10. There we go, nice better size. So my counter bore socket there as well. Last one then is we can choose on the top, we can then obviously do a countersink. So keeping it in line. Let's put that at 80. And that one then 10 again. So this time I countersink. I could put a tap countersink this time, so I could sort of say, well, I want an M10, I want 1.5, that'll put my countersink approaches in for me as well. I could do a clearance on my countersink. It really depends on what kind of fit that you want. Through it all again. Let's do 12. There we go. So it's got 12 mil countersink on a nice tapped hole, so if our tap socket will come all the way down. So that's everything you can do with the hole command. So what else we could do is also have to reference this every single time. If we make a new sketch on the surface and we use the point tool, which is located in here, I could actually do a point. Now I could say one that's 10 mil from the edge, for instance. Okay, then I could come in and make a rectangle pattern or a straight line pattern. So that's my object. Direction along the base. And I could say I want it to travel across 125. Or actually, no, let's just say 100 because I want to go all the way to the edge. I could say I want 5 holes. 1, 2, 5. That'll do nicely. That gives me 5 points. Finish my sketch. Now when I come in to my hole, I can now choose multiple holes from sketch. Select my holes. 5. I can say now I want a clearance. A clearance for an M8. My profile, and I get 5 holes exactly the same. It's quite a strange countersink there, but let's look at those features again. It's a clearance. That's because it wasn't through all. So distance, let's go through all. And again, that seems very small for an M12. So again, you can just keep going and editing the features. There's M2, that's one. Let's do an M8. Again, that's those features there. So the last one is to do threads. So what you could do is you could obviously make another sketch. I could put a hole in. I can make a 12 mil hole. Okay, I can obviously come to a solid. I could push pull or extrude this out. So all cut. Okay, like so. Now I can come to my thread and I can do a nice internal thread. So I can pick up my thread. And pick up it's 12 mil hole, 12.175, or I could choose 1.5 or 1.25. This time I'm going to do a fine thread 1.25 and okay that. I'll put my thread in. A bit more of a long-winded way than putting a hole in, to be honest, but it does also work that way as well. Now obviously what's very good this function is if I was going to do the reverse. So if I come back, new sketch, I could put a hole, let's do a 12 hole, circle, let's do a 5 hole. This time I'll use push pull this time to show you a different way to do it, but let's do 15 high, like so. It's now got like 3 kind of. Now if I come into my thread, I can then choose obviously per, so 1.8. I can then come back in again, thread, it'll pick up this one to 12, which is done, and it should pick up the last one's of 5. So obviously putting external threads on is really good because it picks up their geometry, like so. So there's every kind of type that you can do, starting from drill hole, into a clearance, into a thread, into threaded taper, counterbore, countersink, multi-holes using a sketch, use a hole cut out with an internal thread, and obviously holes extruded with a external thread as well. So that's how to use all the different holes and thread functions within the system. Okay, so thanks for listening to that. And obviously you can follow along for the next sort of load of videos on the how-to series.